Hyde Park, Vermont is a rural town located 50 miles east of Burlington. North of the town is one of the most dangerous intersections in the state of Vermont. Entering from the south is a local road, Church Street. This road has low traffic volume entering and exiting. Entering the intersection from the east is a combination of Vermont 15 and 100. Vehicles entering from this direction do so at high speeds, continuing through the intersection on Vermont 15 or turning right onto Vermont 100. Entering from the west is Vermont 15. Most vehicles continue east on Vermont 115, but a high volume turn north on Vermont 100. Entering from the north is Vermont 100. This is particularly problematic because most vehicles turn onto Vermont 100/15 without a protected left turn. There were 23 accidents at this intersection between 2002 and 2005, of which at least 26% resulted in injury. Although VTrans has redesigned the intersection and construction will begin this summer, our group was tasked with redesigning the intersection from scratch. Here is our design team. From left to right are Tyler Helm, Warner Clark, Steve Spear, Dominic French, and Jimmy Maurer. The first thing we did was to analyze traffic data of the site. Of particular interest was the uneven distribution of traffic volume through the intersection. Outlined in red are all the traffic movements of at least 100 vehicles per hour during peak traffic conditions. Our next step was to develop courses of action. In initial discussion, we identified 4 possible design solutions. They were to install a timed stoplight, a roundabout, move the intersection, or build a large interchange. Moving the intersection or building a large interchange was eliminated because they would require taking large tracts of privately held land. In designing a timed light intersection in the roundabout, our primary design consideration was to increase the safety of the intersection with secondary considerations including reduced congestion and ease of movement. Design of the timed stoplight revolved around the addition of protected left-hand turn lanes. These would reduce the number of vehicle operator decisions by dictating which traffic movement would have the right of way. The geometric design of the roundabout is important to ensuring a safe intersection. The geometric parameters were taken from the Federal Highway Administration guidelines. For both designs, the increase in area of the intersection required fill and cut volume calculations, as well as additional pavement. Using the site soil data and the existing contours, these volumes were calculated. Due to the predicted instability on one of the slopes of the intersection, a retaining structure called a gabion wall was designed to contain the slope in state-owned land. For both designs, stormwater facilities were specified to retain as much runoff on site as possible, thus minimizing the effects of storm events on adjacent properties. Ultimately, our group had to decide on one of the 2 designs to recommend. To recap, we had fully designed both a traffic light controlled intersection and a roundabout. Our design criteria were to increase the safety of the intersection as well as its usability. However, the almighty dollar always has a say. In comparing the 2 designs, our recommendation was to implement the roundabout. As safety and flow would be improved by both designs, the 2 factors which drove our recommendation were wait time and cost. Wait time is the amount of time a user could expect to take to negotiate the intersection, and was slightly lower for the roundabout. The cost estimates we prepared indicated the construction of the roundabout would cost slightly less. We believe that building the roundabout we have designed will decrease serious accidents, increase traffic flow capacity, and provide a more sustainable approach to transportation engineering.